Okay, so this is Thermodynamics II homework solutions for the South Dakota School of Mines and Technology. This is number 6 of homework 6. Homework 6 is Raoult's law for adults, vapor-liquid equilibrium, azeotropes, all that good stuff. Okay, and so problem number 6 is specifically 8.19. Okay. And it's saying, so if I look at Koretsky 8.19, so if you're at home and you're not in my class and you're like, oh, well, we use Koretsky, then okay, well, this might be an impertinence to you. And it says a liquid mixture, so I know Xi containing 1, 2, 3, 4 components. They're all very similar, so I can probably assume an ideal solution. So I can assume Raoult's law for kids. Raoult's law for kids says YIP equals XI PI sat. Okay, so I know Xi, I know the pressure at 1 bar. I'm trying to find, so I don't know, Yi, and I don't know T. And as a result, I don't know PI sat. Okay. This is a bubble temperature. Okay, so bubble temperature. All right. But I approach these problems all the same. It doesn't matter. Okay, so I have this guy. All right. I'm also missing, I'm missing the equation. I'm missing, summation of yi equals 1. Okay. All right. Now the difference between bubble and dew temperature from bubble and dew pressure is that, okay, I could kind of, I got pressure in this equation, so I could just kind of jump right into it, okay? Because I had pressure as part of my equation. I don't have temperature as a direct part of my equation. Temperature is buried in PI sat, okay? And because it's buried, it's not just buried, I mean it's really buried because it's in an exponential term. Because I'm going to use Antoine's, so I have natural log of PI sat is equal to AI minus BI over T plus CI, okay? And because it's buried in that thing, in that manner, I can't just kind of do the algebra like I did the bubble pressure or the dew pressure, okay? So I need an initial guess for temperature just to get things going, okay? Otherwise, I don't know too much, okay? And so, how do I get an initial guess for temperature? All right? Well, I know Xi's, and so what I want to do is I want to guess the temperature as a summation of Xi Ti sat, okay? Because I know the pressure. So I can find the temperature based on that pressure. Is that going to be the temperature of my system? No, but if I look at a TXY diagram, it looks something like this. Okay. Really what it is it's, every line, every point on those lines is essentially somewhere between the two saturation temperatures. So if I use a weighted average, it'll get me in a ballpark at least. I mean, it won't be exact, but it'll get, it'll be close, okay? And so I want to get Ti sat. Well, how do I get Ti sat? Well, I solve for this guy. And so Ti sat is equal to Bi over AI minus natural log of P being the system pressure, okay, minus Ci. I'm going to use that same equation again, but this time it'll be P sat and T versus Ti sat. So I'm only going to do this once. I just need a guess. I just need a starting point. Okay, so I'm going to get each Ti sat using this guy, and I'm going to plug it into here, and I'm going to, get a weighted average, and that's going to give me a T. Okay, so now I have a value for T. Okay, so I don't know that guy. I know this guy. I know this guy, and I don't know that guy. All right. But once I have T, well then I can get, so I get a T, I can get saturation pressures now, okay? And so now I have a value for saturation pressures, okay? So I'm going to use this and get all my PI sats. Using the exact same equation, it's just this T is going to be this T gas, okay? So I now have a value for pi sat. So I'm only missing one thing in terms of what do I have a value for. Okay. In terms of yi. Okay. And so yi is equal to xi pi sat over p. Okay. Do I know I have value for xi? I do. Do I know I have value for pi sat? I have value for it. Do I know I have value for p? I do. So I could get all my yi's. Great! So do I have or know, do I have value for or know everything in there? I don't know everything, but I have value for yi, I have a value for pi, I have a value for xi, I have a value for pi sat. And so once I have a value for everything, I ask myself, what's the first thing I guessed, what's the first thing I got a value for? And that was t. And so I need to get a new t. How do I get a new t? Because I can't really do the same thing I did before. I need to come up with a unique way of getting t. All right, well, I have something that is only a function of t. What is only a function of t? Pi sat. Pi sat is only a function of t. Now I have two pi sats. Which one should I do? Well, it's the Mills principle. You get to pick it, okay? And so I want to use this equation. Say the t is equal to, b1, a1 natural log of p1 sat, c1. Okay. Because I have value for p1 sat. Okay. The problem is, though, if I use p1 sat, as is right now, I'm going to get the exact same t I got there. So I got to do something. I got to change p1 sat somehow. I got to update it. I got to tweak it. Okay. Well, what equation have I not used yet? What equation is staring me in the face that I haven't used yet? That's right, the summation of yi equals 1. Okay, well I have yi. Okay, so summation of xi pi sat over p should equal 1. And let's face it, it doesn't. Why? Because the temperature I used is garbage. And so my pi sats are all going to be garbage. Okay. And so instead of saying this equals a 1, because I can't just solve for the temperature. I mean, the temperature is embedded in a bunch of exponential terms, and there's just no way I can do this, okay? But what I can do is I can use a weighting factor. I can say, okay, that equals some fudge factor. That should be 1. When I'm all said and done, it will equal to 1, but right now it's a fudge factor of omega. And so when it's all said and done, that will equal to 1. But right now it's not equal to 1, and it will fudge something. And I already talked about what do I want to fudge. Oh, I want to fudge p1 sat. I want to fudge p1 sat, so I can plug it back into here and have a fudged t. All right? Now, so I want some p1 sat new. I want to fudge p1 sat original, or old. Okay. Now, the real question is, though, should I divide by that fudge factor, or should I multiply by that fudge factor? I'm not enough of a mathematician to understand why. But I do know that I always want p to be in the denominator. In the numerator. Okay. For whatever reason, as a fudge factor, I want p in the numerator. Okay. Otherwise, I'm going to diverge versus converge. Okay, and so to get this in the numerator, I need to divide by my fudge factor. Okay, and so that's like 1.01 or whatever. Okay, I'm going to fudge this guy. I'm going to plug it back in here, and I'm going to get a new t. What did I do after I got a new t? Oh, I got pi sets. What did I do after I got pi sets? Oh, I got yi's. What did I do after I got yi's? Oh, I said, oh, what do I need to do? And I went back here. Okay. And I'm going to keep doing this in an iterative manner until my t doesn't change. Because eventually, my t won't change. And so my pi sets won't change, and this will equal 1, and then, 1, this divided by 1 is going to be that, and that won't change either. Okay. And so I'm just going to keep doing that, over and over and over again. And, now, it doesn't matter if I use 1 or 2 or 3, no, it doesn't matter. I just use 1 because it's convenient. There's always going to be at least one component, but I could use component number 4 in this case. Okay. Yeah. So that's all you need to do.